Calculate the variance and standard deviation for a standard fair cubical die. So let's look at the distribution. Now this is one we should know fairly well by now. So 1, 2, 3, 4, 5, 6. And we know that all of the probabilities are 1/6. And to shortcut this example, remember that the expectation of x, which we've worked out before, is 21/6, or 3.5. Now, we need the expectation of x squared. Well, that's going to be 1 squared times 1/6, plus 2 squared times 1/6, plus 3 squared times 1/6, plus 4 squared times 1/6, plus 5 squared times 1/6, plus 6 squared times 1/6. Now, you can take the 6th out and then just do 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared. So that's going to be 1, add 4, add 9, add 16, add 25, add 36, which gives us 91. So that is 91/6. Now, if the variance of x is the expectation of x squared, take away the expectation of x squared, then we know that that is going to be equal to 91/6. Take away 21/6 squared. I'm just going to put this in standard over here, and we'll do that as 91/6. Take away 21/6 squared. And that's 35/12. As a decimal, that's 2.916 recurring. Now, we go to statistics, we can do this as well. And whether you do this out long or whether you go to the statistics package is really determined by the number of marks available for the question. If it's only a couple of marks, I wouldn't be doing all of the work that I've done so far. So we've got 2, 3, 4, 5, 6, and then all of these are 1/6. So 1/6, 1/6, 1/6, 1/6, 1/6, and 1/6. And then we can go to calc one variable, and our probabilities were in list 2, so we need to tell the calculator we were in list 2, and we'll click OK there. Now, you'll see at the top the expectation is 3.5, the mean is 3.5, and you can see the sigma x value here is 1.7078. Let's just put that down there. That was the value for the standard deviation here, sigma x. So the standard deviation of x we know is the square root of the variance. So if I just hop back over to main and we do the square root of the previous answer, and let's just go to decimal, 1.7078. So you can see that you can get the standard deviation, and you could square that to go to the variance. But you won't get an exact value. You'll only get a decimal. So if you need an exact value, then you will need to work it out long form as we did at the beginning. So like this.